Hello, thank you for joining us today. Today we're going to be reviewing ATAGO's PAL Milk refractometer here. So for those who are not familiar, it's a rather special refractometer in that it will look just at the non-fat milk solids within your sample. So obviously this is just going to concern, uh, different milks. Not going to have a different measurement principle per se, as it will still use refraction like any of our other refractometers. However, we are on a slightly different scale from 0 to 23% for the non-fat milk solids. So this could have a couple different applications, but certainly if you're checking to see if your milk sample has any sort of additives involved with it and looking for that extra cross-checking measure, this would be a great unit for you. You'll probably also notice we have the PAL pH right next to it. So if you haven't had a chance to check that out in terms of the design, feel, just basically how it works and the range, we will be taking a look at that directly afterwards as well. I did want to mention that because these are digital refractometers, you are going to have things like NFC for reviewing your data, exporting your data. You are going to have a digital representation of your reading. So these are certainly nice little perks to have that you don't have with a traditional style of the analog. So we'll take a first-hand look at that as well. So first things first, I wanted to give you guys a quick close-up of the PAL Milk and just sort of how it's designed and what we have involved here. Go ahead and change our view here. So this is, for those who have checked any of our other past meetups here, this is actually going to utilize the exact same design. We have the 100-gram compact design here, ergonomic shape. We have the nice angles here for easy runoff of the sample when cleaning. And then of course this is our sample stage here. Your eye's probably drawn right to that blackish area in the center. So this is our prism. That's actually where the refraction is occurring. The light will come from the inside of the unit and project outward, and that's how our measurements are being obtained. We are not using external light sources to generate those readings as you would with an analog. So that's all happening in the prism and the surrounding sample stage area there. We do also have a couple of buttons. As you can see, there's the start and zero. Zero setting I will show you guys in just a moment here, but that's essentially going to get a ground zero established so we can have that reference point, so to speak. So that's basically all you have in terms of the buttons. You can do a couple things with those, which we'll hopefully get a look at here. You can see on the bottom side here, this is a battery cap where all you need is two AA batteries. And you've got a little lanyard hole here for easy transportation and getting about with the unit. So very simple design, nice compact feel. So we'll take a quick look at our whole milk here, and you really don't need much at all. 0.3 milliliters is all you need. See, our unit is powered on. Go ahead and put in 0.3 milliliters or so. And it's really, with the Mode S technology coming into play, we are getting a nice quick reading there. So every second we're at that 12.3% non-fat milk solids. And just to give you guys an idea, we will make sure that this is kind of acclimating if you're using a refrigerated sample or a warmer sample for whatever reason, always good to keep in mind that that is going to have a direct correlation with the bricks, or in this case with the non-fat milk solids that is displayed. So you do want to make sure that you control that temperature as much as possible. And one way you can do that is actually with a little add-on that's provided with this unit itself, and that is the Magic here. So this is the metal version of our Magic. So you can actually insert this in with the sample, and that's going to help get that right to a controlled temperature. And obviously, if there's any sort of external interference, so to speak, this will help keep the sample controlled. So we're getting closer to that same reading, 11.8, 11.7. So all you do with that Magic is make sure you have ample sample volume on there, insert it there, go ahead and hit start one more time. Nice repeatability there, 11.8. So as our sample temperature is nearing that 20.8 degrees Celsius and stabilizing, we're getting a very consistent readout. So this actually is going to feature plus or minus 0.2% in terms of how much you can see that reading fluctuate, but we're getting a lot of really good results here. So just something to keep in mind with the Magic. It may or may not come into play, but just a nice little add-on, because if you are dealing with a milk sample, you may see refrigerated, you may see warmer samples. So just good to get that stabilized a little bit quicker, so you're not wasting as much time. Keep in mind that this unit does have ATC, so it's going to do a lot of the work for you. If you're looking at 10 to 100 degrees Celsius, the unit is going to automatically compensate when it's generating those readings. So pretty cool technology, to be honest. I want to give you guys a quick look at some creamer here, so probably a slightly fattier sample that will use that Mode S technology. And I should mention that this unit here is actually IP65, which is really nice. This is ingress protection rating for those who are unfamiliar, but it's essentially going to enable you to put this unit under running water, and you are going to have that added protection against dust as well. So nice and durable. We wouldn't suggest submerging it in water, but you are more than welcome to run the sample stage right under that water and get your sample off in an efficient manner. Probably best to also utilize your Kim wipes as best you can, or any other sort of lint-free wipe. So we have our 0 set done, the unit's still on. We can just jump right in and get slightly different sample type here. We are seeing LLL, which again is going to indicate insufficient sample volume, but that's okay. We should now have enough on there. And we can see we're at 20.6, so pretty close to that target that we were at before, probably rounding room temperature here. And again, we're getting that nice repeatability within 0.1%. So again, theoretically, if I were to change the nature of the sample if I were to change the temperature, we would see this readout here on basically on a constant basis every second. We would see that actively represented. Because things are pretty stable here, we're seeing that same measurement value, but very high repeatability, as we can see.